So yeah, we have supervised, unsupervised. With supervised, we have labeled data. So an example of that would be let's say we have one PNG, and this is class 0, 1, etc. So we just have that label, which is how we're able to train the model by telling it exactly what the correct outcome should be. So if we feed it this file and we tell it it's going to be this classification, it looks at it and then it goes, okay, I know it's this, so anything similar to this file, I'm going to group it in this classification. Unsupervised is a little bit different. What you do is, let's say for an unsupervised learning problem, we're going to try and graph out factors that influence housing prices. So let's say a house, it has the attributes of square footage. We have buying price. We have like bathroom count. And then we could do like POCs. So we have points or POIs, points of interest, where we have like distance to a school. If you live near a middle school, your house is going to be worth more for a single family home. So what we do is we'll treat this as a vector. And this is the SVM that I was talking to you about. So if we're just putting it like this is kind of how we'll treat the attributes for, let's say, house 1. This is X1, okay? When we graph all this stuff, it's really hard to visualize something in the space that we're going to do, because we're going to use the kernel trick to expand and make even more attributes so that we can see a relation between these attributes that might not necessarily have such a profound impact.
What's the kernel trick?
So the kernel trick is going to be, here's probably the best way to explain it. Let's say we have this vector, we have 1, 2, okay? And we graph that, so we go 1, 2, okay? So that's where this data point is.
Yeah.
And then if we do the kernel trick, what we're trying to do with the kernel trick is expand the amount of conditions that we're examining in order to classify something. So if I'm saying I want to classify you, okay, you have brown hair, brown eyes, light skin, okay? Well, that applies to a lot of people. So let's get a little bit more specific. Facial hair, blue shirt on, pants, you start expanding, trying to get more information to understand it. You're taking the data that you have and expanding it.
Just
sometimes
adding more traits to it.
So technically the example I gave you is not the kernel trick, but that's conceptualizing the effect it has. What I was telling you was adding more features. So like making a 5, 6, 7, and then considering that stuff. What the kernel trick would be doing is the data you already have, you're changing it so that it can be a different row. So like, remember when I told you you want the picture of the gun, but in order for us to identify the gun, we need to see a picture of the gun facing like this?
Yeah.
Like you change it slightly?
Change the angle of it so that...
That's the kernel trick, basically. But instead of, this is an easy way to visualize it, but the data side is going to be like that. So what we're doing with the kernel trick, by expanding it, we have a 2-dimension right now, and then let's say and so we use a kernel trick to make x2. think it's like right here or something. But this makes it where, let's say for housing prices, we have 4 houses, and square footage is the main determinant of what price you can sell your house for. Well, we see that they're not really that highly correlated. It's kind of hard to see a relationship between them, and it's really hard to make a linear fit where you can predict. So what you do is you expand it into a higher dimension where you can see, okay, in this dimension, the number of bathrooms actually does have a more profound effect on the selling price of the home. So what I showed you with the kernel trick and the SVMs, that's one of the number 1 ways to do unsupervised.
So, well, we're doing supervised, right?
Yeah. I was just briefly going over
unsupervised
that.
is just much like, it's like more complex because
Unsupervised data, unsupervised machine learning is finding patterns in the data without
Because you
being
can't-
explicitly told.
because you
what
can't
they
just
are.
like classify it, right? Or-
Yes. So what you do is, the reason I was showing you the vector,
Mhm.
every single data point is going to have this vector, right? And we plot that on the graph. And this is a simple 2D graph showing the clusterings, but in reality, these most likely would be hyperplanes in much higher dimensions than just, 2 dimensions. But this is how it would work. You would use something like a KNN, K nearest neighbors, and what it does is every time a new data point is added, and also keep in mind, this is unsupervised KNN. So every time you have a new data point put into the graph, what it does with K nearest neighbors, it runs a distance formula to where you see who's closest, right? And based on who's closest, you're grouped in the red, right? Even though it's slightly outside where the rest of them are, it's still close enough that it could be classified as that, right? If you have any questions about KNNs, we can come back to that later. But now we can focus on the actual supervised machine learning. I'm gonna move this over here real quick. Well, you understand labeled data, right?
Mhm.
Okay, I don't need to keep that up there then. Okay, so let's talk specifically about your project. Okay.
That would be unsupervised, right?
Your project?
Yeah.
Well, let's write out what your project is first. Isn't it theft metrics, magic, universal?
Yeah.
And that could be like,
Well, are we just only focusing on that, or could it be?
well,
like,
it would be like all stadiums in Florida,
Yeah.
all
Yeah.
attractions in Orlando, like something like that.
Well, let's just focus on stadiums then.
Yeah, so just for the sake of this lesson, we'll just talk about merchandise theft at. Okay, so what you're probably going to use is, talk me through this again. We have, what was I saying you need to do? You create a machine learning model to determine how much you're losing or where you're losing it in the.
I think it was how much.
How much?
Yeah, it was
losing?
how much.
Okay. So that's pretty simple then. You don't even need to do really any machine learning for that. What you'll do is gather your data, and this should be gather your historical data first. Yeah, actually, you could. So, okay, let me explain this real quick. We've been talking about classification, right? In order for you to predict, let's say, a percentage of sales that you're going to lose at a game, that is an actual number. It's not a, this is um, a Mazda versus a Chevy. This is legitimately 6.32%, right?
Mm-hmm.
So that's called regression. So, yeah, this is all classification. Regression would be like, my house is located here. It has this width, this height. What should my predicted selling price be? It's like 4.2.
So that's just stats, right?
What it's using is it could be using a neural network, and at the end, instead of having an activation function, it doesn't have one, so it just gives you the percentage or the continuous value. We can talk about that in just a second. For your project, let's say a neural network, no activation.
How do we create a neural network? Like you
So-
say that a lot, but like where do I how do I make that?
So a neural network, let's talk about how it works first. So there are many different ways you can set it up, but I'll do it like this. Obviously, there would be a lot more of these, but just for the sake of demonstration, I'll do it like this. Okay. Oh my God, really messy. Wow. So, you know how with any function, any computer program, really anything that you've learned, there's input, output, right? So, boom, we have input. And boom, we have output. So the way it's gonna work is we have our training data, right? So like what we're talking about for our project with the gun detection, what we're gonna have is, this is inside the train folder. We're gonna have this list of name, class, right? So we have train, okay? What we're gonna do is we're gonna take, let's say this is 10,000 images. We're gonna split this 90-10 as he wants us to. So 90% is gonna be training, 10% is gonna be testing data, okay? So what we're gonna do is this 90% that we have training data, we have access to this label, so we can tell for each file that we're passing through, we know what the outcome should be, right? So let's think logically. Let's say the first file, 1.png, this is class 0 or handgun, okay? So 1 goes through. It starts looking, since we're going to be using a convolutional neural network, what we're going to be doing is using a computer vision model to be able to analyze what is in the picture, okay?
Yeah.
So what we do is we pass 1 through, okay? And of course, during data pre-processing, we need to pad the images and make sure that we have spatial hierarchy. I'll explain that to you really quickly. Okay, let's say we have this image and it's of a gun, okay? If the gun were in the top left corner, it's going to be in a different space, right? The X and Y values objectively for where it is in the second image is going to be different from here, right?
Mm-hmm.
So if we train the computer vision model, computer learning model, only to have pictures where it's in the center, it's going to only look in the center of the frame to find the gun. So we need to maintain something called spatial hierarchy, where it could be placed anywhere on the frame and you should still be able to identify it. So the way we do that is using padding. So we'll take the original image and we'll create like a little exterior border around it. That way, the way that it works with a CNN, we have this gun. The way machine learning models work is it's going to go pixels, right? So we're going to take a cluster of pixels. We're going to analyze it. Okay, RGBV, that's all white. There's no edges, there's nothing there. Okay, keep moving. Now we go here. Okay, we've got a little bit of something there, blah, blah, blah. And we're going to be pooling the layers together. And we're just going to keep moving around the image until we have a full like grid of values. And then we can identify, okay, that's a gun. Do you get what I mean by that?
Yeah.
Does that make sense to you?
Yeah.
Okay. Padding makes sense, why we do that.
Mm-hmm.
And then pooling, moving around the frame. That makes sense?
Yeah.
Okay. So then I can do this. We pad, and then let's say we have a pooling layer here. We have a hidden layer here. We have another hidden final pooling, and then right here we're gonna have our output, and this is going to be with an activation. So these activation functions that I keep talking about, the most common one's going to be ReLU, and what it does is it takes this input and it tells you what this value is going to be. So each node is going to have a coefficient or a weight, and that weight is going to affect its decision on which node to go to next, right? So they can be set to whatever values initially. I think normally they're set to like a negative or a 0 or something, and then you just do like a minimum and you can adjust it like that. So we have 1. We know this is a handgun, okay? We go through in our pooling layer, we start looking around the image, we're noticing, okay, there's an edge, it's black, it has somewhat of a rectangular structure, it has blah, blah, blah. So we go through all of these things and it updates the weights based on what it thinks is important to identify this image. We go through. We do that for all the images in our training, our 90%. Then once we're done, what we'll do is this output, it's going to be handgun, long gun, right? And it's going to be associated with each of the images. So we will check against the labeled data that we have. So we go through one. At the end it says, okay, this is a long gun. Wrong, we know it's a handgun. So then we do something called backpropagation. Backpropagation, where normally we're working input to output, we work output to input. We have something called the cost function. And this is going to be telling us how accurate our model is, okay? So at the end here, we have an error. We have maybe like 29.3% error or something, okay? We want to go back and see at each node, how much do you contribute to that overall error? So at this node, let's say it's 0.001 that it contributes to the total error. Well, you're going to modify the weight at this value, change it to fix the error, right? And to reduce the error. You do that all the way back through to the input, and then each of these weights are gonna be different with the idea that it's minimizing the cost function so that you can put in an image and it should still be able to identify it correctly. So yeah, we go through, we use back propagation to minimize the cost function and make these weights as accurate as possible. That's all of the training phase. Then we're gonna test it. So remember how I told you we have this list of all the file names and what class they are, and we split it in 90% we're going to let the machine learning model see, and 10% we're not gonna let it see. Now it's time to test it on the 10%. So we're only gonna show it the name. We're going to, or sorry, not the name, we're only gonna show it the image. So we're gonna feed in this image of a handgun. We'll say this is like number 3. We feed it in, and it goes through, gives its prediction, okay? This is a handgun. But it doesn't have something immediately going, no, this isn't a handgun, this is a long gun, or you did it correct, right?
Error, right?
It doesn't know if it got it right or wrong. We're testing if it's right.
It's like, it has like a percentage of error.
Yeah, so you can do starts with a C, confidence interval.
Confidence interval.
Yeah, you can make it where within a certain range, you can say it's gonna be this class versus this class.
Usually.
Yeah, you can do something like that. But once it has this testing data, it's gonna go through, and there's no one telling it whether or not its output is correct. We're just gonna see what that is, and we're gonna use that later. So we do that for all of the testing. We have all of their outputs, and then we're gonna do an evaluation. We're going to compare what we know is true and what we got. So we have predicted is what we're supposed to have. That's the correct answer. And then our real is going to be what actually is output. And then based on that, you can determine how accurate the model is. Okay? Does that make sense?
Yeah.
So once you have the training and testing phases done, it's ready to be implemented. So what we're going to do with this whole process of training the CNN, does that make sense to you?
So for the most part, yeah.
Okay. For your project, the only thing would be different is, one, you're going to have to rely on historical data completely for your training data, because you're predicting something in the future, and we have no way of knowing if your prediction is right or wrong until it happens. So what you'll do is gather all your historical data, this time, like date, time of day, what was stolen, how much was stolen, where was stolen, like those attributes that you need to know for the stadium, right? For the, yeah. And then you'll feed it through, treat everything as a data point. You could do a clustering KNN algorithm where you have these data points, then you cluster it by like 50% stolen, 25% stolen, 75% stolen, something like that. So you could do that, or you could do a neural network where you don't have an activation function at the end. So instead of giving you a classification, it gives you an actual number, a numerical value, and that's what you can use to determine theft at magic. And this wouldn't be a CNN, this would just be a neural network with some hidden layers. But yeah, do you have any questions? Anything I could expand on? James, anything?
How far would I have to gather data? Like, how far in the past?
Gather as much as you can, and
Because also, like, they might have, like, input more security or certain technology.
well, yeah, you need to account for that as well. That's something that you can treat as an attribute. And something, because you can't look at how much was stolen in 1950 compared to now. You know, we have more enhanced security and measures in place, or maybe less. You don't know.
Well, the stadium's only like 10 years old.
Yeah.
12 years old.
Well, you get the point I'm trying to make. Like the historical data, and definitely with the basketball team, there's what? How many games a season? 82. You have
Plus playoffs.
You have a pretty good amount of data right there for 10 years.
Well, I mean, there's also other stuff that goes on in the stadium, like concerts and
Yeah,
like performances.
it's just gonna be. It might be more difficult to have access to the theft data, like merchandise theft data for a dance competition, compared to an organized
Yeah.
NBA game,
Yeah.
I'm trying to think if there's anything that I'm missing. And of course, this is a very high level overview. The math is crazy, and even just like the activation functions, I briefly touched on it, but it definitely goes a lot more in depth. And this is just, I only showed you a KNN and a CNN or a neural network. There are other ones as well, like the SVM that I was talking to you about. You could use that as a binary classifier. And like we could use an SVM for this, honestly. It could just be gun, not gun, handgun, not handgun.
Is there a way for it to automatically update as time goes by?
The machine learning model to automatically update?
Mm-hmm.
So
like I wouldn't have to like input more data, like it just
So-
extract the data itself.
I don't know all of the industry practices or even all of the research practices. From what I've understood in my class and what we've done here is look at ChatGPT, okay? You have GBT version 1, okay? And then now we're all the way at 4.0, right? We have generations. Think about Black Ops. Black Ops 1, 2, 3. It moves through. So you have a product where it's at a certain level, and then you keep increasing, and then you release a new product. So what I imagine is we have this trained neural network. In order for us to truly be working on machine learning, we need to apply the principles of machine learning, which is continuous improvement. So after we have this made, we should always still be expanding the training and testing data sets that we have available, and we'll keep running it. But from what I understand, right when we go through and we create this GBT1, we can push that out to the public and have that kind of locked. But then we'll retrain it and keep expanding, and then that'll be GBT2. And then publish that, expand the data set even more.
So it's like a yearly thing?
It's not yearly.
Well, I'm saying like when you output a new version like every year because there's new data.
It could be every 2 weeks. It could be
every 2 weeks. Okay.
It could be once this
But then
month.
you would have to input the data yourself every time.
Yeah, you're gonna be expanding this data set and creating more and using that to train.
Yeah, my question is there a way for the data to be inputted like automatically? Like for it to maybe like scrape itself?
Yes. There actually is a way to do that. You would need to, it depends on the way your database is structured, okay? So also for your project, you're gonna need to gather data, right? So you're gonna be using maybe like pandas, or you could do some SQL. I'll explain SQL, or I'll explain how you would do it in SQL. So let's say you find
How I'd gather data or how it automatically
like how you would gather. I'll explain both. Okay. So let's say you find this NBA report, public knowledge, everything. It's all fine to be used for your project, so you don't need to worry about that. It's in this format. You have, the picture of the guy. You have his name. You have weight, height, home address, you know, all these like stats and metrics. Like imagine this is a player profile, okay? We have like shooting percentage, field goal, all that, okay? And what we want to do is, this isn't really that useful to us in this format. It's easy for humans to read, but computers, you hand that to it, it's like, what am I doing? You know?
Wait, what project are we talking about right now?
We're talking about how to organize and gather data.
Okay, I was just, you were saying like shooting percentage and stuff, like that doesn't matter.
Here, I'll keep it.
Like, isn't this like theft? Right?
Yeah, you know what? Let's treat it like this. This is a loss prevention officer who works for the Orlando Magic. Their name, their address, how long they've been working, how much was how much did they report stolen at last game, the game before, all that. Okay, so we have metrics, right? And this isn't in a useful format for us right now. So what we want to do is create a database. So in the database, we want it structured like this. Employment, and then we'll do theft 1, and then we'll do like theft 1 will be theft percentage for like the first game, theft 2, second game, yada yada yada, right? So we want to get into this format, but we also want to make sure that this database can be updated later, right? So we'll use a SQL query. We'll do create table report, and then you remember what you've learned about the ER diagrams. You have primary keys, foreign keys, just your attributes, all that stuff. That's going to go in here once you create your table. Okay. So we created this table. Let's say ID is our primary key because that should be unique. Name might not be unique. You might have 2 guards that's named John, but their ID numbers should be unique. So we'll treat that as the primary key. Then in order for it, so this is getting to your point. In order for it to automatically update, what can we do? Okay. So let's say we have this table report, okay? And Jim gets hired at the Magic. New employee, he has no reports yet, and then for the first game, he makes his first report, okay? So what we can do is use something called a trigger. Let's say this report is ID will be a foreign key for this other table, which will be our train table, okay? And just for the sake of explanation, it's going to have every column here in this train table. This is the same training, okay? So everything here is going to be used to train the neural network. What we can do is create trigger TR, and we'll do like on update report, insert into train, or yeah, insert into train, values, old dot, blah, 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 like old dot name and all that stuff. So we create a trigger. So the immediately when Jim, ID 123, 0 years of experience, he reports a 32% theft in the first game. Immediately when that gets added to the SQL report, we have a trigger statement, TR, where this report has been updated. So we insert these values into train. So now we have Jim, years experience, all that. And that's how you could automatically update it. But that would just be updating the training data set. You would have to give that training data set to the machine learning model to train on. Yeah. Like you can't have it where, let's say the directory structure is like this. You have LPRC, research, train, test, and you can't have it where this training data set is here, stored. Take that back, you could, actually. What you can use to automate your training. So we have this trigger, right? It's automatically going to insert all this stuff. But how do we make it where the machine learning model itself will periodically check for updates and retrain itself? Well, what we can do is use one of the Python libraries for date and time, and then just make it where we use, you could do like a Boolean condition where a certain amount of time has passed. You could do a while loop to make sure a certain amount of time has passed. But you can make it where you set up the program to where it will automatically run. So include date, time, code, and then when you get to the train model section, here's what we'll do. We'll say, we'll make a variable. We'll do next week. And we'll have that equal to 7 days, or you might have to do, I think you have to do minutes, so you would convert that to like, I don't know, like 60,000 minutes or some stupid shit, okay? And then while next week, and then run the training. And what you can do is just treat it as a Boolean where either yes, it's been 7 days, or no, it hasn't been 7 days. So the idea with that is, let's just talk about it like football, okay? Because football is a lot easier. You have 1 game per week. That's it, right? So let's say for each game, I want to know how much theft happened at the Bucs Stadium, okay? So we have it automatically update for each week because we're assuming a game happened, and we're going to have that data, that new data that we need to process and understand, and then we'll just do that and run it. But yeah, I think that pretty much sums up everything that you need to know for your project.
Mm-hmm.